Welcome to qnawire.
In this question, we have a collision between two moving blocks. So before the collision, we have a 5 kg block, okay, moving at 3 meters per second. Then it collides with a 10 kg block, moving at 2 meters per second. Okay, and then after the collision, the 10 kg block moves at 2.5 meters per second to the right, and then the 5 kg block also continues to move to the right. Okay, so I'm going to label this as V1F. So this is M1, M2, M1, and M2. Okay, so there are 4 parts in the question. We want to calculate the final velocity of the 5 kg block and the change in total kinetic energy of the system, and what happens if the 10 kg block has a final speed of 4 meters per second, and account for the change. Okay, so in part A, we want to find V1F. Okay, so to do this, we'll be using conservation of momentum. Okay, so we have M1 V1I plus M2 V2I is equal to M1 V1F plus M2 V2F. Okay, then you put in the numbers. M1 is 5, V1I is 3, and then M2 is 10, V2I is 2, and then 5 V1F plus 2 times 10 times 2.5. Okay, right, then you rearrange. You can divide 5 throughout, and you realize you can get V1F to be 7 minus 5, which is 2 meters per second. Okay, so this is the final velocity of the 5 kg block. Then in part B, we want to find the change in kinetic energy. Okay, so delta K is equal to half M1 V1F square plus half M2 V2F square. So this is the final kinetic energy, and then you subtract the initial kinetic energy. Okay, so let me write something before that. Okay, it's K final minus K initial. Okay, so K final is the first 2 terms, and then the K initial will be the last 2 terms. Okay, right, then you just put in the numbers. Okay, I'm going to put the M1s together. So put in the numbers times 5, 2 square minus 3 square plus half times 10 times 2.5 square minus 2 square. Okay, so this is minus 1.25 joules. Okay, so this is the change in kinetic energy. Okay, and in part C, we want to find the change in kinetic energy if the change in total kinetic energy if the 10 kg block ends up with a speed of 4 meters per second. Okay, so with V2F equals 4 meters per second, so we need to recalculate our V1F. Okay, so 5 times 3 plus 10 times 2 is equal to 5 V1F plus 10 times 4. Okay, so we end up having V1F equals to 7 minus 8 equals to negative 1 meters per second. Okay, and then the change in kinetic energy. right? So you just put in the numbers. And you get 40 joules. Okay, so if the 10 kg block has a final speed of 4 meters per second, the change in kinetic energy is 40 joules. Okay, then in part D, you want to account for this increase in kinetic energy. So there's a loaded spring that decompresses during the collision. Okay, the stored potential energy in the spring is converted to the final kinetic energy of the system. Okay, so this is how you can account for the increase in total kinetic energy of 40 joules. Okay, and that's all for this question.